So and we're going to do it comparing it to exponentials, because you've seen exponentials now. The properties kind of line up with each other a little bit. So, Christian, be quiet. Okay. So, exponentials. What is that equivalent to? This is a y.
Yeah. That's the y.
Would it be 4xy?
No.
It's a y.
We're going to have it combined. They have the same base and they're multiplied. What do you do with the exponents?
X plus 1.
Yeah, there you go. Add the exponents.
I knew.
Very good. Now if you do the same thing with a logarithm,
It would be different.
same concept. They're multiplied together, correct?
Yeah.
You can split them. And add. Okay. So those are just kind of relationship there. What?
Put log 2.
What?
On the
What?
log 1, would you put log 2?
I did not put a base on that logarithm. What's the base of this log?
Log. Isn't it 10?
10. If you don't write a base, it's 10. So a common log.
No matter what.
We will get more into that Thursday. So, you probably remember this property now. Subtract, right? 2x minus y. So, making that comparison to that logarithm there, what do you think it's going to be?
Log x minus log y.
Right. Okay. Remember this relationship? Anything with 0 power is 1, correct? How would I write that as a logarithm?
Would you actually, I don't know, would you actually
Base
put a
is
base?
2.
Yeah.
What do you do with these numbers? Any log at 1 is 0.
Oh yeah, you told us.
I did. That we went over last week.
It was too long.
Okay, here's there are a couple of things with logs that are a little bit different than exponentials than anything you've really ever seen. Okay, so these are the ones that kind of screw with people a little bit.
Right.
You know, math teachers are like, screw it. No. But this is something that is very useful at times. Is if we have a log okay, now there would be a base here, base 10, 2 to the power of x.
What is it equal to?
Okay. Is equivalent to that. So if you have an exponent on a logarithm, you can bring it out to the front and multiply it. So it's kind of weird. It's one of the things that actually allows us to use logs without a calculator. Okay. It will would be roughly equivalent to, what's the base here, 10?
Yeah.
10 base. How could I rewrite that? You just asked a question that gave me a... These are the same thing, correct?
Yeah.
Remember that exponential property? If you have an exponent power to a power, you can multiply them together. It's the same idea as that. Okay. Those two properties are reciprocal properties. It's just not very obvious. Okay, those are your log properties. Okay. So basically, memorize both those columns. That's what you're looking at. Okay. We'll make some cards for them. Sound good?
Yeah.
We're probably way behind on those, aren't we?
Yeah. I think we've done it like 3 months. I think our
No,
last
it
time
hasn't
we
been
did was
3
in
months.
January. Well, I haven't done it in
3
No,
It might be 2, but I'm not gonna say 3. Okay, so we'll make some cards for you. Okay.
Jerry's never done one.
Jerry
doesn't do them.
is that Homer gonna be manipulating both of them?
That's good stuff.
I think it's just logs
Okay.
in this one. Yeah. There might be some spiraling with exponentials.
Yeah,
But
I wish I could.
all right, so these are how we're going to use these properties to solve equations with logarithms. So let me give you a...
That'd be all right.
Are they both number 2?
That's 1/3.
Wow, that's ugly.
There are a couple ways to deal with logs. One is to use your properties of logs to solve it. One is to change to an exponential. This one's a great one to change to an exponential. So, do you know what 64 to the 1/3 is first?
4.
Yeah. So log x 4 is a half. Notice I did not move this out front like that property says, because this is easy to solve. So we write it as an exponential. X to the power of 1/2 equals 4.
Did we do x equals 4? No.
You can write it like this if you'd like. Same one, right? And then solve how do you do that? Square both sides, you get x equals.
That is a lot easier.
Yeah, a lot easier to just rewrite as an exponential, right? Sometimes you don't have that opportunity, but if you can, that's what I would do. Questions there?
See, it just takes me to remember how to switch them back and forth.
Oh, you wrote that really fast. Is that plus 11 or plus 9?
11.
So log base 4, 2x plus 11 equals log base 4 of 5x minus 4.
How do you just cancel out the log? Yeah. Can you cancel the log? Because they're both the same bases, so they're basically the same.
Yeah? Hey.
Yeah, so same base is correct, so exponential to the power of 4, those will both cancel out. So what you end up with is just a linear
Expression.
expression.
A lot easier than.
Go ahead and solve that.
Oh, gosh, it's not that hard.
That's so much more easier than what we could have been doing.
Christian is defeated on so many levels right now. Anything is hard. I'm just kidding.
It's called the X equals,
Ouch.
X equals 5.
Dude, that escalated
X
quickly.
equals 5. So, and I didn't even do the math. He told you to do it. I didn't. Yeah, I didn't know. Dick carries weight for
Okay, good?
Start listening.
Good.
So remember that property equality there, it'll help. Okay, here's a little bit more difficult, so let's go with log base 11.
What is a real
Can we take
algebra?
another one?
It's literally every time you say it, it's the same thing, right? So just it's not the same thing. No, it is the same thing.
Is that X plus 1 or X plus 4?
1.
Yeah, I don't know how to do this.
Here's a property. So notice how your bases are the same. Always look for bases that are the same. See the plus between them?
Yes.
Okay, so
So too long.
looks like this, correct?
Yeah.
So what can I do with those?
Oh, wow.
Combine and multiply, right?
See.
Okay, so I can do log 11 x times x plus 1.
So x squared. That's x squared? Yeah.
So I combine and multiply, just using that property.
No, x squared plus x.
So log 11s, they cancel out, right? Same log, so I get
Now solve for that.
solve that equation.
Dude, you can just choose that and solve that. Well, I don't know.
Solve the quadratic. Go.
Now you don't want to, you have to.
Put on your paper.
Done.
If you have to remember that equals 0, you get that first step.
Oh, yeah.
Now
I know.
solve the quadratic.
I knew it. Wait, it's minus 3 x plus 3.
Oh, no.
Something 3 and 2. Oh, I thought you added to get the no, next time. If I would do yes. Okay, so 2 and 3 adding to the yeah.
The great debate, plus 3 or minus 3?
Minus 3.
I don't care.
In this part, it's plus, so our answer yeah, you're not done yet. You have, because, so, logarithms are not defined for negatives. Okay? So can I have a negative in here? I cannot. So negative 3 does not work because logs are not defined in the negative x values.
Oh my god.
So negative 3 does not work because we can't plug it in here. The 2 works.
Oh, see, I didn't put it in the original law. You're not used to thinking, Christian. You're the one that talks.
They show you graphing these on Friday, Thursday?
Definitely not on Friday.
There wasn't Friday. No. Thursday, they show you the graph logs.
Yeah, I do know.
You okay with that?
Maybe you're
Yeah,
All right, man.
all right, then it's just fine.
Know how to solve log equations. It's fun.
Oh, you did though. Why is it not that bad? Yes, you know, you're just not pushing through. Yeah. No, sleeping. Yes. I can't avoid it.
This is gonna be due Thursday.
All right.
We'll start NWA testing tomorrow. Yeah, I know.
NWA.
The reason I'm like, and then Thursday we'll do 11.5A, and Friday we'll finish NWA. I try to alternate because this gives you 2 days to do this. Okay, so, but number 77 is degrees, minutes, seconds problem, so I gave you the degrees.
Number 77 is 105 degrees. Stop class after I am testing. I'll just be doing it.
You can, depends on how much money you have.
Okay. Probably, you're probably not enough.
Probably not.
Yeah, probably not enough. Especially since, yeah, definitely not enough. You're like part-time